Let's see image formation in refraction. Concept is same. Intersection of incident rays. In reflection, we used to say that intersection of incident rays gives us an object, and intersection of reflected rays, that gives us what? An image. In refraction, we say that intersection of refracted rays, that gives us what? Image. Everything else is same regarding object and image. Let's start with this air and glass interface. Let's say this is air and this is glass. Something is present inside glass. This something is object. From the object, we draw at least two rays so that we can find the intersection point. This is one. This is another one. These two are incident rays. Intersection of incident rays gives us what? An object. That's what this object is. Then this first incident ray is moving along the normal and therefore it suffers no deviation. It goes straight like this. The second ray, let's draw normal at this point. That's normal. Since you are moving from denser to rarer, this incident ray will deviate away from the normal. Moves like this. That's your refracted ray. First refracted ray, second refracted ray, intersection of these two refracted rays will give us what? Image. And that intersection takes place somewhere here. This is the point where the intersection takes place. First refracted ray, second refracted ray, the intersection takes place at this place. This is the position of image. Now, why did I draw this thing with broken lines? We'll see that later. A little bit of idea you already have from reflection. This thing must be virtual. We'll discuss real and virtual later. Just the way image formation takes place, you need to follow this much part only. Have two incident rays, the intersection will define object. Corresponding refracted rays, the intersection point will give you what? Image. Now, what is this image? Who is seeing this image? Who can see the object? These are the things which matter a lot in refraction. In reflection, observer was present always in front of the mirror. There is no way you can place an observer behind. It doesn't make any sense. For any type of mirror, we used to say front side is what? Real. Back side is what? Virtual. It's very easy to define real and virtual. Now in here, these two refracted rays are being observed by this observer. There is an observer outside in air. He finds these two rays coming out from the glass, and then his brain goes for intersection point of these two rays which are coming out. Those are refracted rays. What he sees, this image. This observer does not see the object. He can see only one thing, and that one thing is what? Image. It's the person who is drawing the ray diagram who knows about what an object is, what an image is. For this observer, there is only one thing, this image. It's like if I ask you, you put a coin in a bucket, fill it with water, and then you look down, then you only see what? One coin. You do not see an object and then its image. You see only one thing. That one thing is what? Image. That's what this observer does. He can only see one thing, and the thing which he sees is called what? Image. Now, if I ask you, what is the medium in which this image formation takes place? What is the medium in which this image is being formed? Take your time, think about it. Mostly people say that this image is formed in glass. But no, that's not correct. Image formation takes place with the help of refracted rays, and therefore this image in this figure is formed not in glass but in air. This image is in air. If you ask this observer, then he does not know anything about glass. What he sees is this image, and for him these rays are in air, and therefore image formation will take place in air. Which means when you put that coin in the bucket and when you look at it, you do not see that coin in water, you see that coin in air, the medium in which your eyes are present. So what we say is that image formation takes place with the help of refracted rays, and image forms in the medium of observer. Write down this point. Intersection of incident rays provides position of object and medium of object is that of the incident rays. Similarly, image formation takes place with the help of refracted rays and image formation takes place, and therefore image formation takes place in the medium of refracted rays. That is in the medium of observer. For example, in the given figure, For example, in the given figure, although it appears as if image is being formed in glass, but instead it is formed in the medium of observer, that is air. That is air. Now, since you found what? Not this guy. You found that it appears in glass, but he says that he is looking at the image in his medium. Because of this conflict, we say this image is a virtual image. This image in this situation is what? Virtual image. Whenever there is a conflict, whenever there is a contradiction, that will give you what? Virtual thing, virtual object or virtual image. As of now, this object is very much real. Why it's real? These are the two incident rays. You can see that these two incident rays are in glass. Their intersection also takes place in glass. There is no contradiction, and therefore this object is real. You found that these two rays are intersecting at this point, but to you it appears that this point is in glass. But now let me prove that for you also this point is not in glass but is in air. Now I asked you to produce this ray and this ray backwards so that you can find the intersection point. Now what is this medium? Air. Now you're producing this ray backwards and it does not suffer any bending. It does not deviate at this point, which means for you also, if this is air, this point is also air. It's just the way you draw the ray diagram which makes things a little bit complicated. Otherwise, overall concept is quite simple. This ray and this ray, what is the medium? Air. Therefore, image will form in air, but since it appears in glass, because of that contradiction, we say it's what? Virtual. We'll see this real and virtual again. In case of mirrors, it was quite easy. In front of the mirror, light rays are possible, that's called real side. Behind the mirror, rays are not possible, that's called what? Virtual side. But in refraction, light rays are possible in this portion as well as in this portion. And therefore we decide what? If intersection of incident rays is in this medium and that thing is also in this medium, then things are real. If intersection takes place in this medium, that thing is also in this medium, real. If intersection takes place in this medium, but that thing appears in this, you will say virtual. Whenever you go for contradiction, whenever you see contradiction, you will straight away say virtual. And then you will learn this thing with practice. Just don't worry. This is the first case. Now let's find out. Let's find out this relation between position of image, which is HI. HI is what? Position of image from the air and glass interface. This is HO. Position of object from the glass and air interface. And we are taking air and glass interface now, and then we'll change this thing from medium 1 to medium 2. But as of now, just to understand things easily, we are saying air and glass. So what do you mean by HO? Position of object, position of image कहाँ से? From the interface of both mediums. Now, in this whole setup, when you see that this observer is looking at these two rays, we are also making one important assumption that somebody when looks along the normal, this image formation is a special case. In this image formation, we are considering along the normal viewing. Along the normal viewing means, suppose you have something here, let's say a coin. If you have an observer right above this coin, then this is the case we are investigating. If you ask this observer, move somewhere here, then for this observer, this coin, rays coming from it, these are what refracted rays. You will go for intersection of these two. We'll see this type of thing later. This is for basically IIT advanced type of thing. Now, in here, we are interested in what? Along the normal viewing. Now, when you say along the normal, all the angles involved will be very, very small. Just so that you can see whole thing clearly, we have taken these large angles. This ray and this ray. What basically is happening? This normal viewing means from the coin, this is one ray, this is the other ray. Now even in this figure, angles are large. Why should they be small? Now, who sees these two rays? Observer. And for that, you use your eyes. Now, you know that your eyes is not this big, and therefore, your eye should be able to, your eye lens should be able to collect these rays. If your eye lens can collect these rays, then it means that you can see that particular image. For this observer, if you take this figure as a true, literally correct figure, then this observer cannot see this ray and this ray both together. Nobody has an eye large which can collect this ray as well as this ray. You will have to have a very large eye, something which is not possible for us. And therefore, remember, this view is just so that you can understand the whole mathematics. In reality, when you say along the normal viewing, it means this is the first ray and the second ray is also almost parallel to the first one. Which means all the angles involved will be considered very, very small. Write down the statement. When we say along the normal viewing, it means all the angles involved are very, very small. And intersection takes place between a ray which is running along the normal. Intersection takes place between a ray which is running along a normal, passing from the object itself, and a second ray which is almost parallel to the first ray, and a second ray which is almost parallel to the second ray. Now aim is to find what? Relationship between HI and HO. Now Now let's use the concept of Snell's law. Where is angle I? That's your normal. This is the incident ray. This is your angle of incidence I. Normal refracted ray. This is angle of refraction R, which means we can write sine I upon sine R. Now if you write mu, be careful. This mu is refractive index of air with respect to glass. Refractive index of the medium in which light rays are going with respect to that medium from which they are originating, and therefore refractive index of air with respect to glass. But in normal situation you are given what? Refractive index of glass with respect to air, and by now you already know this thing, that this will be 1 upon refractive index of glass with respect to air, which you can simply write as 1 upon mu. What is mu? Refractive index of glass with respect to air. Now, once I say sin I upon sin R is this, I told you that this is normal viewing. If it's normal viewing, then this sin I upon sin R can be approximated with I upon R. Because angles are what? Small. And therefore sin I can be approximated with I. Sin theta becomes what? Theta if angles are small. And again, this I can be replaced with tan I, and R can be replaced with tan R. What is happening? This is happening. Sin theta can be approximated with theta, which can be approximated with tan theta, provided theta tends to 0. If theta is very, very small, sin 0 is 0, which is what is tan 0. Now, once you write tan I upon tan R, I hope you can see if this is I, this angle is also I. If this is R, then this angle is also R. R. This is I, this is I. Now, let's say this much portion is X. If this is X, what is tan I? What is tan of I? Perpendicular X upon base from this to this. What is the base? HO. This tan I becomes X upon HO divided by tan of R. What is tan of R? X perpendicular upon base. What is this base length? This base length is what? HI, and therefore tan R becomes X upon HI. X and X cancelled. X and X cancel. This HI jumps into the numerator, and you get HI upon HO equals to 1 upon mu, or you get HI as HO divided by mu. Divided by mu means you can see that position of the object divided by mu, which is greater than 1, which means HO upon mu is definitely less than what? HI. For glass, you know that mu is what? 3 by 2, 1.5. We are dividing HO with a number which is 1.5, and therefore position of the image, which is HI, will be, for this type of setup, always less than HO. It will help us in remembering something which will we see later. As of now, note down this whole process. Note down this much. Let's see the second situation. In the second situation, what is happening? Say, again, this is air. Let's take this medium as water now. This is air, this is water. In the previous example, object was present in denser medium. We had glass here and object was present in glass. This time object is present in rarer medium. That's your object. If this is the object, then I hope you can guess where the observer lies. If this is the object, then your observer lies in water. That's your observer. Now, how do you go for image formation? First ray. This first ray runs along the normal, passing from the object itself. This is incident ray. This is your refracted ray. Incident ray, and that's your refracted ray. Then you go for what? Second incident ray. That's your second incident ray. And then you draw a normal. That's the normal. This incident ray is coming from rarer medium and is entering into a denser medium, and therefore it bends towards the normal. That's your refracted ray. Intersection of incident rays, it gives us what? Object. Intersection of refracted rays will give us what? Image. This intersection cannot take place this side, and therefore you need to produce it backwards. And let's produce it backwards. Do what? Draw a solid line first, join it like this, and then break it. If you are drawing it with the help of a pencil, you can always do that. Remember, from this, it should be a solid line. From this, it should be a solid line. Why? Because things are real. We'll discuss it. These two, you're producing backwards. From this point onwards, this side, and therefore you're drawing all these lines as broken lines. This is your image. That's your image. Now, let's first decide real and virtual. Intersection of incident rays gives us what? Object. That's your object. This object is in air. Why? Because incident rays are in air. This object appears also in air. That means there is no contradiction. If there is no contradiction, then this object is what? Real. Now, let's go for image. Intersection of refracted rays, that gives us what? Image. Refracted rays are in water, and therefore image should be in water. This image is in water, but to you, not to him, to you it appears in what? Air, and therefore there is a contradiction, and you say that this image is virtual. When I say to you, not to him, if you ask him, then he just does not know about anything which is called air. For him, everything around him is what? Water. And therefore, image formation it takes place, we say that in the medium of observer, this virtual image is getting formed in what? Water. Whereas the object, it's very easy for it, you can see, is in air. So, whenever you need information regarding image, what is the medium of image? Medium of image is same that of observer. What is the medium of observer in this figure? Water. And therefore, image formation takes place in water. We'll use this information later on. Now, let's go for Snell's law and find out relationship between HO and HI. Now, what you should do is pause the video, use the same technique of Snell's law, sin I upon sin R, take small angles and find out relationship between HI and HO. If your final answer is such that HI mathematically is also coming greater than HO, then things are correct. If you cannot, then come back and see the solution. So let's go for angle of incidence. This is the incident ray, that's your normal, and therefore this angle is I. If this angle is I, then this much is also what? I. Two parallel lines, and therefore this is also I. That's your R. If this is R, we produce this ray backwards, means this angle is also what? R. And if this is R, then let's use Snell's law. Sin I upon sin R is refractive index of the medium in which light enters, water, with respect to air. Refractive index of the medium in which light enters with respect to that medium from where it is coming, starting from. And we take this number as what? Mu. And this is sin I. You know that sin I upon I, sin R, since angles are small, will become what? I upon R. This I upon R can be approximated with tan I upon tan R, which is what? Mu. Now again, take this distance as what? X. What is tan I? X upon HO. Tan I is X upon HO divided by tan R. Tan of R. Look at this right angle triangle. Look at this right angle triangle. Tan R is what? X upon this whole thing, which is HI. This is called X upon HI, which is coming mu. X cancelled. This is HI divided by HO, which is mu, which gives us HI as mu times HO, which is correct in agreement with the observation. HI is what? Greater than HO, because mu is greater than 1. That's how image formation takes place. Now, we have developed two situations. In the first one, you can call it case 2, and the previous one, call that what? Case 1. In case 2, what is happening? Object is present in the rarer medium, and observer is present in what? Denser medium. And in just few minutes we will see that we'll develop a format where it doesn't even matter which one is rarer, which one is denser. But as of now, for this particular setup, you can note down this, that this case 2, write down case 2, and with case 2 mention that object is in object is in rarer medium, object is in rarer medium, and observer is in the denser medium. An observer is in the denser medium. And what happens in this type of situation? You will find that distance of image from the interface. Remember, all these distances are taken from the interface of both mediums, the common junction point. That's it. This distance of image in case 2 will be always greater than what? Distance of object from the interface. And do one thing with that case 1, previous article, case 1, go there and write down case 1, and with case 1 mention that object is in denser medium. In the previous article, go there and write down this. In case 1, object is in denser medium and observer is in the rarer medium. Object is in the denser medium and observer is in the rarer medium. Whenever case 1 type of situation takes place, you will find that distance of image from the interface is always less than the distance of object. If you put a coin inside a bucket, then you will find, you must have noticed it yourself, that that coin appears a bit higher from the actual position. So these are the two cases, case 1 and case 2. But now let's see if it does matter that we should investigate these two cases separately, or we can generate something with the help of refraction concept which we developed in previous lectures. Let's say this is your medium 1, mu 1. This is your medium 2, mu 2. This is mu 1, this is mu 2. Then this Hi upon Ho, which is coming mu, Hi upon Ho, which is coming mu, is simply what? Refractive index of 2 with respect to 1. Refractive index of 2 with respect to 1. Generalized situation. What is mu 1? Now, it's no longer air. Suppose this is water, this is glass. Then what is mu 1? You will say refractive index of water with respect to air. If nothing is written here, that means air. Similarly, if this is glass, then you will say that refractive index of glass with respect to air. So for us now, these two mediums are no longer air and water. They are just two media, medium 1 and medium 2. That's all. Which one is denser, which one is rarer, you don't have to worry about it. That thing will be taken care by Snell's law. Hi upon Ho is refractive index of 2 with respect to 1. And you know what this is? This is refractive index of 2 divided by refractive index of 1. This is something we have already seen, this type of part. Now, what is mu 1? Mu 1 is this medium. Which medium? Air. What is air? Medium of the object. And therefore, let's now change mu 1 with mu object. What is mu 1? Medium of object. What is mu 2? Mu 2 is medium of image. Image. You don't see it here, but that's not the case. These are the refracted rays. Intersection takes place here. These rays, they are still in what? Water. So, what is mu 2? Medium of image. You just need to remember this, and therefore I stressed on this point that what do you mean by intersection of incident rays, or what do you mean by intersection of refracted rays, and in which medium that intersection takes place. So this is mu object, this is mu image, which means this hi upon ho is what? Mu 2. What is mu 2? Mu image, mu I for image, divided by ho, mu 1. What is mu 1? Mu object, mu o. From now on, for case 1 or case 2, simply remember this formula. Hi upon ho is what? Mu I upon mu o. All these distances, they are taken from the interface of both mediums. Suppose we had the case 1 type of situation. In case 1, what happened? In case 1, we had glass, this was air, object was in this medium, this was the medium of observer. You remember that image formed somewhere here, that was the position of image. If somebody wants to use this formula of hi upon ho as mu I upon mu o for this situation, then what they do this. First, let me remove this part. So, look here. This is your air, glass, observer, object. This is something which you already know. They will give you that object is in glass or in air. The moment you decided this, you will straight away go for what? Hi upon ho as mu I upon mu o. Simply remember this line. Hi upon ho is mu I upon mu o. Then, what is mu o? Object. Object is in which medium? Glass. Write down mu g. Image. Image forms in the medium of observer. Remember the statement. Image forms in the medium of observer. What is that? Air. Write down what? This. Now, the refractive index of air with respect to air is what? 1. And the refractive index of glass with respect to air, we had taken it as what? Mu. You are getting what? Hi as ho divided by mu. It's this much simple. You just have to remember one format for case 1 or case 2, that is hi upon ho is mu I upon mu o. The only thing you need to know is image forms in the medium of observer. Object forms or is present in the medium they are given it to you. If it's real, if it's virtual, we'll see that later. Now, that's how you take care of all these distances and real and virtual part. Next, we'll focus on real and virtual a little bit more with the help of same air, water or water air interfaces. But first, note down this much. Let's see real and virtual again. This is air and this is water. Air and water. And now incident rays, they are coming like this. These are the incident rays. These two are your incident rays. And these are incident rays. Then if I ask you where is the normal, where is the object, then you will go for intersection of these two incident rays, and that intersection will take place here. Incident rays, you will produce them like this, but then in this form. Why? Because from this to this, medium is changing, and therefore you cannot draw a solid line, a solid ray. This is the incident ray. We have produced them just for the sake of finding position of what object. This intersection point gives you what object. And if I ask you, this object lies in which medium? Air or water? And take your time, decide it, and now verify yourself whether you guess the correct answer or not. Object formation takes place with the help of incident rays. Incident rays are present in air, and therefore this object is in air. But to you, it appears in what? Water. It is in air. To you, it appears in water. There is a contradiction, and because of this contradiction, this object is what? Virtual. How do you decide object? Intersection of incident rays. Remember this point. Now, once you found this intersection, then let's draw the normals. Light is coming from rarer into denser. Rarer into denser, and therefore it deviates, it bends towards the normal like this. It bends towards the normal like this. That's the bending. This is intersection of refracted rays, and therefore gives you what image? This was your object. This is your image. Now what is the medium of image? Is it real or virtual? Decide it. Now look here. Intersection of refracted rays gives us what image? These refracted rays are in water. If refracted rays are in water, then this image is also in water. To you, it appears in water. It is also present in water. There is no contradiction, and therefore this is what? Real. Can you see a similarity with reflection? When we had reflection at plane surfaces, we used to say that if object is real, image is virtual. If object is virtual, then image is real. Same thing is happening in this situation. When you have refraction at plane surfaces, if your object is virtual, then image is what? Real. And if your object is real, then image is virtual. Now, to someone, it may look something which is highly conceptual. But somebody who remembers the very first lecture of ray optics, he will simply say that it's nothing but application of law of reversibility. Somebody says that this is the incident ray, this becomes refracted ray. Law of reversibility says what? If this is incident ray, then this becomes what? Refracted ray. If this is incident ray, it is the object, and that object is what? Real one. These are what? Refracted rays, and therefore this thing is what? Virtual. But if you are not interested in this much law of reversibility and all, then you can simply remember a statement and write down that statement. For refraction at plane surfaces, if object is real, then image is virtual. If object is real, then image is virtual, and vice versa. Now, let's find out if the formula which we developed, hi upon ho equals to mu I upon mu is still valid or not. Let's see. This is what ho, this is what hi. Ho. Our observation says that hi is greater than what? Ho. Hi is greater than ho. That's the observation. Now let's see if this observation fits the mathematical representation. Mathematical representation is hi upon ho equals to mu I upon mu o. Object is an air, and therefore mu o is simply mu air. Image is in water, mu I is mu water. Hi therefore is ho multiplied by mu. Mu water is what? Mu air is what? 1. You can see that you're multiplying ho with a number which is greater than 1, 3 by 2. That means hi is what? Greater than ho. From this, that's your observation. They both are same. So from now on, you don't have to worry about whether things are real or virtual. Rays are coming from rarer into denser or denser into rarer. You always use hi upon ho as what? Mu I upon mu o. Remember, only if you view along the normal, so that all the angles are what? Small. Note down this part. Now, there is a homework for you, and the homework is we have taken, you can, if you wish, you can call it case 3, although it hardly matters. You can call it case 3, and for you, the homework part is you will yourself develop case 4. What is case 4? Take air and water, but your object should be in water. In here, object is in air, which is rarer medium. Now, what is case 4? Write down this. In case 4, object is in denser medium. Object is in denser medium and is virtual. Object is in denser medium and is virtual. Your object is in water, but is what? Virtual. That's what you need to discuss. What is case 3? Object is in rarer medium and is what? Virtual. And then you will see and verify 2 things. First, application of this format, and the second thing, whether the statement holds true or not. Virtual and real, this type of thing. Since you are using a virtual object, the image which you get should be real. That's the homework. Note down everything.